Welcome to the deep dive. Today, something I know you're super interested in, programming fundamentals. We're diving into parts of this introduction to programming course, and I think this will be really interesting, even if you have never really looked at code much
It
before.
really is amazing how important these like basic programming ideas are. They're like everywhere,
Yeah.
even if we don't realize it.
Yeah, totally. Okay, so first things first, what is programming? Like, our source material says it's like giving instructions to a computer, kind of like a step-by-step recipe, but for a computer task.
Oh yeah, that's a great way to think about it. Just like if a chef writes down all the ingredients and the steps to make something, a programmer, they write code. It's like step by step to tell the computer what to do, and the computer, well, it's like this super powerful tool that can do those instructions really fast and accurately.
So are we basically like learning a whole new language so we can talk to computers?
Exactly. And we call them programming languages. And just like with languages people speak, they've got their own words and rules and little quirks. Things like Python, Java, C++, those are just a few examples. And each one is, well, it's kind of best for certain things.
Makes sense. So are there some like core building blocks that are in like all these different
Oh,
languages?
for sure. Think of it. Imagine building a house. You need those key things, right? Like bricks and beams and mortar. Well, programming, it's got key concepts too, like variables, data types, and operators.
Okay, I'm starting to get the picture. Can you break down what those actually do? Like, let's start with variables.
Sure. So a variable, it's like a container. It holds a piece of information. Let's say you're making a program to keep track of a player's score in a game, right? You can make a variable, call it something like player score, and that would hold the number, the score. As they get more points, that number in the variable, it changes.
So it's kind of like a storage unit that changes while the program is running.
Yeah, exactly. Now, say you also want to store the player's name. That's where data types come in. You'd use a different type, maybe a string, for text information, like a name. Each data type has its own rules for how you can work with the data.
So are data types kind of like categories to organize information within the code?
Exactly. Numbers, text, true or false values, all of those are different data types. That's really important because it tells the computer how to understand and work with that information.
It's starting to feel like we're like building something piece by piece. So we have these variables to hold different types of data. What's next? How do we make the computer actually do stuff with it?
That's where operators come in.
Hmm.
They're like the actions, the verbs in our programming language. Think of things like adding, subtracting, multiplying, dividing. Those are all operators.
So if I wanted the program to calculate the player's total score after, say, they finish a level, I'd use an operator to add their current score and the new points from that level, which are all stored in variables.
Exactly. Operators let us do calculations, comparisons, all sorts of actions with data.
This is pretty cool. But I'm guessing it gets more complex than just, simple calculations. How do we create like logic, like the kind of decisions we make every day?
Ah, good question. That's where control flow comes in. Think of it like creating a roadmap for your program. It tells the computer what order to do things in. Like when you're playing a game and you come to a fork in the road, you got to choose which way to go. Control flow statements, they're like forks in the road for our code.
So we can create what, branches and loops and stuff to
Yeah.
control what happens based on certain conditions.
Exactly. Like an if-else statement, it lets the program pick between two different paths, depending on whether something is true or false. And loops, they let us repeat a chunk of code over and over. Super useful when you need to do something many times.
Oh, okay. It's like we're giving our code like decision-making powers, making it
Okay.
smarter. But then how do we keep track of all these instructions, especially as programs get more and more complex?
That's where functions come in. They're like mini programs inside our main program. Each one does a specific job, and we can call on it whenever we need it.
So instead of writing the same code again and again, we just make it into a function and like refer to that.
Exactly. Functions make code so much more organized and reusable. Imagine like building a website where lots of pages have the same header and footer. Instead of writing that code again and again for each page, you just make a function for the header, another for the footer, and call them up whenever.
It's like building with like pre-made parts. That makes the code a lot cleaner, huh?
Exactly. That's really important in software development, breaking big tasks into smaller chunks you can reuse.
I like it. It's starting to feel like a well-oiled machine.
Ah.
But, we are writing code in these languages, and then the computer is reading and running it. So how do we make sure the computer, like, actually understands what we want it to do?
That's a great point, and it brings us to syntax. Syntax is basically the rules for how we write code in a specific language, like grammar rules, but for computers.
So just like we need to follow grammar rules in English, we need to follow syntax rules when we code.
Exactly. Each programming language has its own syntax rules, its own quirks. And if we don't follow those rules, well, our code won't work. It won't run.
All about clear communication with the computer. Gotcha. But even the best programmers make mistakes, right? What happens when there's an error in the code?
That's when we got to debug.
Yeah.
Debugging is, well, it's finding and fixing those errors, those bugs that always seem to sneak into code. It's kind of like being a detective. You go through the code line by line, figure out where the problem is, then fix it.
Sounds like debugging takes patience and being super detail oriented.
It does, but it's also pretty rewarding.
Yeah.
When you finally find that bug and fix it, it's a great feeling.
It's like solving a puzzle, right? You got to use what you know about the code to find the solution.
Yeah, exactly.
Hmm.
Debugging isn't just fixing mistakes. It's also about understanding the language better, paying attention to details, getting better at solving problems in general.
It sounds like programming is about way more than just writing code. It's a whole set of skills that are useful in life too.
You got it. Programming helps you think logically, solve problems, pay attention to detail, and be persistent. Those are good skills for anything you do.
Wow, we covered a lot in this first part of our dive. We talked about variables, data types, control flow, functions, syntax, and debugging. But this is just the start, right? I'm excited to see how this all comes together in the real world.
Yeah, me too. In the next part, we'll look at how all of this applies to things we use every day, from simple games to super complex AI systems. We'll see how programmers use these building blocks to make cool stuff and push the boundaries of technology.
That's awesome. Can't wait to dive deeper. Welcome back to the deep dive. I'm really pumped to see how all these programming fundamentals we talked about actually work in, the tech we use all the time.
It's wild, right? How those little pieces like variables and functions end up making everything, from a simple calculator app to like some crazy AI.
Yeah, it's like we're learning the secret code behind it all. So let's say a mobile game. What's happening in the code that lets us play it?
Well, think about it. When you're playing, your score, it has to be tracked right. That's a variable at work, changing as you play. And the game's got to remember what level you're on, how many lives you have, all that stuff. That's all variables storing information, just like we talked about.
So even a game, which is for fun, uses all these programming concepts.
Well, totally. Functions, for example.
Hmm.
They're huge in controlling what happens. Like when you tap to make your character jump, that's a function being called to make that happen. Every little thing you do, every animation, it's all code based on those basic principles.
I see. And it's not just games, right? Think about social media, shopping sites, even the Maps app on our phones. They all use this stuff.
Exactly. Imagine how complex a social media platform is. Millions of people using it at once, posting, liking, messaging. That takes some serious programming skills to build a system that can handle all that.
Makes sense. What about super advanced stuff, like AI or those self-driving cars? They use the same basic ideas as a mobile game.
At the core, yeah. It gets way more complex with, super fancy algorithms and tons of data, but those basic programming ideas are still there. Variables holding data, functions doing actions, control flow making decisions.
So it's kind of like building a huge skyscraper. You start with a strong foundation, then you can build all sorts of crazy stuff on top.
Perfect analogy.
Yeah.
And as things get more complex, the type of programming language you use, it really matters. Remember we talked about procedural, object-oriented, and functional languages?
Yeah. Do those influence how you build something really big?
Definitely. So procedural languages, they're good for things that are like step-by-step, like
Yeah.
system scripts or processing data. But for something massive, like a social media platform, you really want object-oriented programming.
Oh.
Well, object-oriented programming, it lets you break down that huge system into modular pieces called objects. It's way easier to manage the code, and it's good for teams of programmers working together.
So it's like having a bunch of architects working on different parts of that skyscraper, each responsible for their own section, and then it all fits together.
Exactly. And then you've got functional languages, which are great when you really need to make sure data doesn't change accidentally, and functions don't have what we call side effects, like in financial apps where accuracy is super important.
It's pretty cool how those different approaches are good for different things, like having a specialized toolkit. But where do algorithms fit into all this? These are the step-by-step instructions to solve a problem, right?
Algorithms, they're the heart of any program. They define the logic, the decisions, the steps that computer takes to do something. Like, think about a search engine. It uses algorithms to decide which results to show you, sifting through millions of websites in, like, a split second.
So it's not just writing code, it's also figuring out the smartest, most efficient way to solve a problem, right?
Exactly. A good algorithm can mean the difference between a program that takes hours to run and one that takes seconds. It's all about being efficient and making sure things work correctly.
And that's where those problem-solving skills come in handy. It seems like programming is as much about, like, creative thinking and logic as it is about knowing the code.
Oh, absolutely.
Yeah.
You need to analyze the problem, break it into smaller parts, and come up with a logical plan that the computer can follow. It's definitely both analytical and creative.
It's like a puzzle, but you get to invent the pieces and the rules. But I bet even the best programmers run into those moments where things just don't work. What about those bugs?
Debugging. It's part of the job. You can plan and write code super carefully, and there'll still be errors.
So it's more about getting good at finding and fixing them than trying to avoid them completely?
Exactly. Debugging is a skill in itself. You got to be patient, pay super close attention, and understand the flow of the code to figure out where things went wrong. Sometimes it's a real head scratcher.
I bet. Like a detective, but instead of clues, it's lines of code.
Mm,
But it's got to feel good when you crack the case, right?
totally. Especially when it's a tough bug. It's a great feeling, and it helps you learn even more about how the code works.
It's all part of the process, right? And speaking of learning, how does learning to program, change how we see the world around us?
It's kind of like you see things differently. You understand the processes behind all this technology we use, and you realize how complex it is.
Hmm.
You start to appreciate the work that goes into making software and the people who build it.
It's like you can see the matrix.
Yeah.
Yeah.
In a way, yeah. And it helps you be more informed and critical about technology. You know more about how it works and what goes into it.
So we've covered the basics of programming, how it's used in real world stuff, and even some of the challenges like debugging. Anything else we should touch on before we blast off into the future of programming?
One thing to remember is that programming is always changing. What we talked about today, those are the basics, the foundation. But technology is always evolving with new languages, new ways of doing things popping up all the time.
So knowing the core stuff is important, but you got to stay curious and ready to learn new stuff as it comes along.
Definitely. Programming is exciting because it's always moving forward. The people who keep learning and adapting, those are the ones who will shape the future of tech.
That's a great way to lead into the last part of our dive. I'm really curious about what's next for programming, what trends are going to be big.
Me too. We'll be talking about some really cool stuff like low-code platforms, AI changing how we code, and even, get this, quantum computing.
Welcome back to the deep dive. We've, gone through the basics of programming, seen it in action. Now let's look ahead to the future. What's coming up in this crazy world of programming?
Oh, there's so much happening. One thing I'm really excited about is low-code and no-code platforms. These tools they're like opening up coding to everyone.
That's pretty cool. So how do they work? Can you really build software without actually writing code?
Well, low-code and no-code platforms, they use visuals and like drag and drop stuff to make it simpler. Imagine building an app by putting together blocks like Legos almost. They hide a lot of the complex code so you can focus on the logic and what the app looks like.
So it's for people who maybe they don't know how to code the traditional way, but they have ideas.
Exactly. It gives so much power to, entrepreneurs, creative people, anyone who wants to solve a problem or build something cool. They can make websites, automate things, even make simple games without needing to be like a coding expert.
Wow, that's amazing. It seems like it could lead to so much new stuff being created. What else is changing the future of programming?
Another big thing is AI, artificial intelligence. It's getting more involved in the whole process of coding. We're already seeing AI tools that can help you write code faster, find bugs, even suggest solutions based on what you're doing.
So it's like having an AI buddy helping you code better.
Yeah, kinda. And these AI assistants are getting smarter all the time. They learn from tons of code and how developers work, so they can give you really useful advice and make things easier. And it's not just about helping programmers directly.
Oh, what else can they do?
Well, there are AI code generators now that can build the basic structure of code or even whole apps based on what you tell it you want. Like you describe your app idea and the AI makes a prototype for you to try out.
No way. That's wild. So it's not just changing how we code, but who can code? too. Anything else on the horizon that's like really groundbreaking?
Okay, this one might sound like sci-fi, but quantum computing is starting to kind of make its way into programming. It's early days, but quantum computers, they can solve problems that regular computers just can't.
Quantum computing? That sounds like super complicated. How does it even relate to programming?
So quantum computers, they use these principles of quantum mechanics to do calculations super, super fast, way faster than regular computers. And that means we can make new algorithms that can tackle like really huge problems, things like, discovering new drugs, new materials, better cryptography, all sorts of stuff.
It's not just faster, it's like a whole different way of computing, right?
Right? And as quantum computing gets more advanced, we'll need new programming languages, new algorithms, new tools. It uses like a whole new world for programmers to explore.
I can't even imagine. It feels like we're on the edge of something huge. So, knowing all this, what advice would you give to someone who's like just getting started with programming?
I'd say the most important thing is to be curious and to really like be interested in technology. Programming is always changing, so you got to want to keep learning. Don't be afraid to try stuff, make mistakes. You learn from that.
It's all about the journey, right?
Yeah. And remember, you don't have to code alone. Talk to other programmers, join online groups, ask for help when you need it. The programming community it's really helpful and friendly.
That's true. There's so much you can learn from others, especially online.
Exactly. Sharing knowledge is so important, especially now with technology changing so fast.
So, to wrap up our deep dive into programming, what's the one big idea you hope our listener takes away from this?
Programming, it's not just a skill, it's a way of thinking. It's about problem solving. And it can let you build amazing things. Whether you want to be a software developer or just understand tech better, learning to program it's really rewarding.
It's about making your ideas real and shaping the future. I love that. Well, thanks for joining us on this deep dive into programming. It's been a blast. We hope you've enjoyed it and that you're fired up to learn more about this incredible world.